Alright guys, this is standard 6 reassessment on rotational dynamics, and the question that I chose to ask: a CD with a radius of 60 millimeters slows from 480 revolutions per minute to rest with a constant negative angular acceleration of the magnitude negative 4.5 radians over second squared. So it asks, how long does it take the CD to stop? And the second part asks, how many revolutions does it turn to come to a complete stop? So I wrote down my known values. I have R, which is 60 millimeters, and it goes to 480 revolutions per minute, and my alpha is 4.5 radians over second squared. Alright, so the first thing I'm going to do here is I'm actually going to convert the 480 revolutions a minute to radians to get my omega to Alright, so what I do here, I do 480 revolutions to 1 minute on my left, and 1 revolution is equivalent to 2 pi radians. So the revolutions will cancel out, and now I need to convert my minutes to seconds. So what I do here is there are 60 seconds in a minute. So the minutes will cancel out, and I multiply across the top values. So 480 times 2 pi radians divided by 60 seconds, which gives me 50.3 radians per second. And that will give me my initial omega, which is the W looking symbol I. And being that we need to know when it stops, our final omega will be 0. Alright, so the formula that I'm going to use is final omega is equal to initial omega plus alpha t, t being the time. So what I do here is I'm going to rewrite the formula a little bit, and I will get t is equal to final omega minus initial omega over alpha. And I will plug in my values: 0 for the final omega, minus 50.3 radians a second is my initial omega, over negative 4.5 radians over second squared. And that will give me, that will come out to be 11.2 seconds to stop. Alright, and the next part of the question asks, how many revolutions does it take to come to a complete stop? So the formula I will use here is 1/2 times initial omega plus final omega times t, which I found in the first problem. So I do my 1/2 times 50.3 plus 0 times 11.2, which gives me 282 radians. And then what I will do is I will convert it back to revolutions. Doing 282 radians is equivalent, well, there are 2 pi radians in 1 revolution. My radians will cancel out, and it gives me 45.0 revolutions.